What about the actual tech that is within the web application? So of course this is the widest attack surface when it comes to trying to break into web applications and web services. So let's review different types of attack vectors you could choose from. But before that, let's review this problematics on the principle level. Okay, so what basically happens on the highest level of abstraction every time the application is hacked, okay, in one way or another. Oh, sorry. What are the places where security problems normally arise? Okay, so the most chances are, the highest probability of security problem occurring is in the area of communication of some different parts of a complex mechanism. Okay, so you probably know or intuitively are okay with the idea that the more complexity in the system, the more insecure, potentially insecure it is. Okay, and this holds true almost all the time. So unless you have kept to the baseline of security principles, methods, and operations while designing, creating, implementing, and running this system, you will inevitably find yourself in trouble, in security trouble. Okay, so what are those connection points? Yeah, what are those edges where different parts touch and interoperate? First of all, there are different technologies connecting to each other. So all the time we need to pass something through the network. Yeah, we have a program and we have a network and we have a program on the other end of the network. We have this interoperation of different layers of architecture. So this machine-to-machine communication will result in higher chances of security risk. Yeah, I hope I described that full and in the same time simple enough to be useful throughout the rest of this section. But what you need to understand now is that the larger is the gap, yeah, the larger is the difference between these two things, yeah, interoperating in this point of connection, the higher are the risks. Okay, so when there is data at rest in a database and there is some data manipulation that like transforms the data, yeah, in the application, and there is data in motion going through the network, yeah, so the risk of compromise is much higher than if there is just a data on a disk. Okay, so I hope this is intuitively okay to everyone. Yeah, so that's what you have to comprehend in order to be successful overall in the security career. So this trigger of elevated security attention, yeah, this large difference between the things that communicate or otherwise cooperate within a complex mechanism or system or application should be really efficient, yeah, to identify the risks properly and in time. And of course, the extreme example of that difference is when human comes to a machine and starts operating it. Okay, so when we communicate to the technology, the difference between us, what moves us, what stimulates us, yeah, what makes human tick, and the machine, yeah, how it's created, what is its purpose, and what is its internals, how it interacts with the outside world. The difference between these two concepts, yeah, these two things, is tremendous. So that's why the most of security problems are right there, between the human and the tech. Okay, so keeping this in mind, let's go further and see what other attack entry points, yes, or what are more specific entry points, what these interactions, what these connection points could look like in the real world. So of course it's access handling. Every time a human or another process has access to an application, sometimes when access is not public, yeah, it's not allowed to everyone, it's essential to have some access control. And handling that access control is a critical task. And a lot of problems arise right there, right? So authentication, authorization, and auditing, yeah, accountability of access is prevalent. Yeah, so that's the first security control you encounter once you start to communicate with an application. So its wide deployment causes a lot of trouble because people have really different perception of what it should look like and rarely follow well-established security principles and frameworks when implementing that. One of the cases of that access handling is, of course, encryption, when we basically render the data unreadable unless the human or a process has access to some key material in order to transform that data back to readable form. And as the first principle of applied cryptography states, you should never implement your own crypto. Okay, so you should always use something that professionals already designed and implemented for you, that's been reviewed and scrutinized by many security cryptography experts. But as we find out when we start reviewing applications, especially web applications, there are people who just try to do that on their own, and that's a bad idea, because once you start to implement your own crypto, bad things pop up all the time. Next, input handling. Okay, so that's when a person or a process provide input for operation of our web application. What happens then? This assumption that the user, yeah, just to generalize, the user will put only useful data into this input control, yeah, it prevails in the developer's mind. So always a software developer is thinking about that. Always he is or she is tending to overestimate yeah, the carefulness of the user who actually provides the input. So input can be tampered with, first of all. Input can be absolute gibberish, okay? So it can be fast, okay? So there could be many ways to abuse input handling in a web application, and thinking that it will work just fine because only a reasonable person can come to the keyboard and type in the data is actually the shortcut to failure in terms of application security. Yeah, so these concepts of tainted and untainted input, trusted and untrusted input data is prevalent in the application security discipline as a whole. Yeah, so we always consider any input data tainted, right? So potentially harmful, unless we control that to required extent. So there are ways to do that. Yeah, there are ways to limit, for example, the range of input values, yeah, to a certain list. Or there are ways just to filter input data in order to escape all control symbols and remove all special characters that can interfere with our further communication to database, for example. Yeah, but sometimes some inexperienced developer just takes user input and concatenates it with SQL statement and passes over to the database, which of course results at least at SQL injection attack, and at most in total compromise of the web application and the underlying infrastructure. So input handling is the second most important, I would say, thing in our list of considerations. Next, storage. Of course, storage of anything on the client side for web applications, it's strictly forbidden. So everything we can store should be limited to cookies only, I would say, because cookies are controlled by a web browser, and that's what we basically should employ and cannot avoid that. Yeah, so if someone has control to the physical storage of our web application on the client side, the user probably has much more important problems than losing access or compromised access to their online credentials. Okay, so this session information, temporarily or permanently stored in a cookie, should be, of course, somehow protected, yeah, by, I don't know, expiration time, for example, or source control, yeah, so once someone is trying to get the cookie from a totally different IP address in a different country, that should be tracked somehow, and most systems do that. But as you remember from the previous section, if we can get a hold of the system physically, okay, if we can own the system like in the real world, there is nothing that can hold us back from compromising all the upper layers of security model, and the web application is not an exception here. Okay, transport. Transport means how data is protected while in motion through the hostile network. Okay, any network for a web application should be considered hostile, just because it's using internet as media for the communication with the browser and the client side. Okay, so the best way to establish that transport security is, of course, to use TLS, previously known as SSL. Okay, so yeah, but there is a separate threat landscape there, as we realized in the last few years. Yeah, so OpenSSL as a framework was quite insecure in application security sense. However, it's getting better. There are forks that are created with security in mind, strictly with security in mind, with no other considerations than security. And personally, I and most of my folks, they think that, yeah, there is perspective in that. So TLS is not dead yet, at least at any sense. So we should use that, and we should try to circumvent that as security professionals, as offensive security professionals. So as long as good ciphers are used and the attack is not deemed purely theoretical, okay, there are still some ways to tamper with what's going on in TLS. Okay, so first of all, we can social engineer the user and let them accept our certificate and then pass all the traffic through our host and just see what happens. Second, we can play with configuration. Yeah, so sometimes the legacy implementations of TLS on the servers that were installed long ago, they just allow defaulting to null ciphers. Yeah, so TLS is still used, integrity control is there, but it's not encrypted in any way. So there are different attack vectors against TLS. However, they are becoming rare. This area becomes very mature, but every time you see that, you shouldn't think just that, okay, they protected their traffic by TLS, there is nothing to be done here. No, that's not true. You have to review the implementation and see how the communication reacts to different tampering attempts. The logic. Okay, so that's where the things start to be really, really interesting. More about that later, but for now, you can think of it as anything that is within application that is not IT or technology related. So every business logic implementation that is on a higher level than just throwing bits around, yeah, and calculating data from inputs and storing outputs, yeah, that is logic. Like, what is the workflow of the application, what steps are taken. So it's like a schema of all paths that could be taken from a starting point to an ending point, or it's going in circles, or it's just a service that repeats some cycle all the time in many threads. So that's all the business logic that actually makes the application usable. And what is the attack entry point here is basically how the business logic is implemented. So there is some sort of observation and imagination all the time, yeah, that results in some planning. So the designer or architect, whatever you call him, yeah, the person that basically is in charge of transforming the business idea, the business logic into application functionality, they just sit and observe what is the specifics of the business process they are trying to automate, for example. Yeah, so they see that there are steps they are taking in certain succession. Yeah, so there is a sequence of different steps, and there is some bunch of if-else conditions. Yeah, so there are some routes between those steps that are taken in some conditions when some conditions hold true. Yeah, so that all on a very principle level is observed. Then some optimization is introduced, and then some schema of business logic to be implemented in the web application is laid down, yeah, as a plan. So the good thing about plans is that they lay out the things how they should be working in normal conditions. And the bad thing about plans is the same. Yeah, they lay out the way things should be working in only normal conditions. As ethical hackers, of course, we are there to generate abnormal conditions. And in contrast to users who just use the logic, yeah, we are sort of abusers that abuse the logic. And every time you see that there is some succession of steps in a certain condition, yeah, you have to think about, and what if this condition is changed, is tweaked somehow? Will we proceed with this succession of steps, or can we take those steps in different order, or can we just skip some steps? Yeah, so if we see the logic that implements a control at certain points, yeah, so we have, I don't know, some integrity control between some really critical parts of application logic. What if we just call the function that should be by the logic, by the plan of the designer, called only if this control has been checked? Yeah, so if everything is okay in terms of this control, what if we just skip it altogether and go to the steps we need? Yeah, based on the architecture of the application, this could be totally possible. Imagine that as you just getting there to the URL and loading the authentication form. Okay, you type in login and password, you press submit, and you get to another URL. So you are like successfully authenticated and then redirected to a certain other part of the application. What if you just take this URL and without any authentication in a different browser where you didn't provide valid credentials, type it in or just copy and paste it? What happens? So this is like the verification of whether the logic is implemented correctly. Yeah, if it's just a physical limitation of your creating inability of an abuser to get directly to that URL, skipping the authentication process altogether. Yeah, of course, technically it can be called authentication bypass, but the root cause of that is the logic problem. Yeah, so the logic of application is not thought through. So every time a designer lays down the plan, he just or she just thinks that, okay, at some point I worked enough. Okay, so this will work like this. And then our task is to go in and challenge that assumption. And the main idea is starting asking questions. And what if it won't work like this? And most interestingly, in security perspective, what if it will work like this and in the same time possibly work like that? Okay, so this is how we deal with the logic in a web application and the application in general overall.